There will not be a single moment when the universe announces that creation is over. No final star is labeled. No cosmic alarm sounds. Creation fades the way sound fades in an empty room, gradually, unevenly, and without ceremony. For billions of years, galaxies have relied on vast reservoirs of cold gas. Hydrogen clouds drifted, collapsed, ignited. Gravity did the rest. Star after star was born, each one a temporary engine converting mass into light. But fuel is not infinite. With every generation of stars, the universe locks more matter into forms that are harder to reuse. Hydrogen fuses into helium, helium into heavier elements. These elements seed planets, dust, and life, but they are poor fuel for future stars. Slowly, the raw material for creation disappears. Galaxies age, spiral arms lose their brilliance, star-forming regions grow sparse. What were once luminous cities of light become quieter, redder, older. Massive blue stars, short-lived but powerful, vanish first. They are replaced by small, dim red dwarfs that burn carefully, conservatively, as if aware that they are the last of their kind. Time stretches forward. Trillions of years pass. Eventually, even the most patient stars exhaust their fuel. Red dwarfs, capable of burning for trillions of years, finally fade into cold stellar remnants. The universe enters an era with no new stars, only the afterimages of ancient ones. The night sky changes its meaning. Where light once signaled ongoing creation, it now represents leftovers. White dwarfs cool into black dwarfs. Neutron stars spin down, their radiation thinning into silence. Supernovae become memories written into the structure of galaxies rather than events anyone could witness. The universe is not dead at this stage, but it is no longer young. Galaxies themselves begin to drift apart more aggressively. The expansion of space accelerates, stretching distances faster than gravity can compensate. Entire galaxy clusters slip beyond each other's horizons. Light emitted in one region will never reach another. Causality shrinks. Each island of matter becomes isolated in an ever-expanding ocean of darkness. From within a single galaxy, the universe now appears empty. No distant galaxies decorate the sky. No evidence remains that the cosmos was ever crowded. Future observers, if any still exist, could easily mistake this lonely region for the entirety of reality. History erases itself. Meanwhile, matter continues to decay in quieter ways. Stars that once orbited peacefully around galactic centers find their paths disrupted by gravitational encounters. Some are flung into intergalactic space, condemned to wander alone forever, carrying fading warmth into endless night. Others spiral inward, feeding the only structures that still grow: black holes. Black holes do not create, they consume. As stars vanish, black holes become the dominant architects of the universe. Not through construction, but through absorption, they merge, grow, and settle at the centers of galaxies like gravitational vaults, locking away mass and information behind event horizon. For a time, this feels like activity. Accretion disks glow. Jets of particles pierce space. Energy is released as matter falls inward. But even this is temporary. As available matter decreases, black holes run out of things to eat. Their surroundings empty. The fireworks end. What remains are massive, silent objects drifting in an increasingly dilute cosmos. And then, something stranger happens. Black holes begin to evaporate. Through a slow quantum process known as Hawking radiation, black holes leak energy. Particle by particle, over timescales that dwarf even the age of stars, they lose mass. The most massive black holes take longer than any other structure to disappear, but disappear they do. This is not destruction, it is subtraction. One of the last mechanisms for change quietly winds down. As black holes fade, the universe crosses another invisible threshold. There are no longer any engines left. No stars, no accretion disks, no fusion, no collapse capable of producing light. Energy still exists, but it no longer organizes itself. Photons stretch as space expands, their wavelengths lengthening until they carry almost no usable energy. Particles drift farther apart, interactions becoming rare enough to be effectively non-existent. Temperature differences flatten. Hot and cold lose meaning. Every region of space approaches the same thin, diluted state. At this point, the universe has not ended in any dramatic sense, but it has stopped doing new things. Processes still occur, but so slowly and so uniformly that change becomes indistinguishable from stasis. Events that once took seconds now take trillions of years. Reactions that once powered stars now happen less often than random chance would allow. Time still passes, but nothing marks its passage. Clocks, if they could exist, would tick without consequence. Each tick would be identical to the last, not because time has frozen, but because the universe no longer provides contrasts for time to act upon. This is the crucial shift. The universe transitions from a place defined by becoming to a place defined by having been. Everything interesting lies in the past. Structure decays, not through violence, but through neglect. Without energy gradients, there's no way to maintain complexity. Molecules break apart and do not reform. Information disperses and cannot be recovered. The universe does not forget suddenly. It forgets evenly. This stage is not yet heat death, but it is the road that leads there. The point where creation ends and survival begins, where everything that still exists does so only because it has not yet had time to vanish. From here forward, the future contains no surprises, only longer waits, only thinner energy, only quieter space. In the next part, we will follow the universe beyond the last stars and the last black holes, into a state where equilibrium is no longer approaching. It has arrived.